Hello, everyone. It's 1 p.m. Eastern, and that means it's time to begin another of our CoCoRaHS Weather Talk webinars. Today, it's our 74th webinar. Wow, that's a lot. A very warm welcome to all of you out there today. I'm your host, meteorologist Henry Regis. Running the technical side of our program is our very own Noah Newman. We're coming to you live from overcast Fort Collins, Colorado. For those of you who are unable to join us for our live broadcast, we are recording today's talk and will make it available later on this week on our website. All of our Weather Talk webinars are sponsored by the generous donations of listeners just like you. Well, you're in for a treat today. Today's webinar is on NOAA's Weather Prediction Center's Winter Weather Desk. Boy, that's a mouthful. Our guest today is Josh Weiss. Josh is a meteorologist at NOAA's Weather Prediction Center in College Park, Maryland. He's been there since 2018 and spends most of the year working rotations on the Winter Weather Desk during the off season of through June through September. Josh works on the MetWatch desk and does some product development. A little background on Josh. He grew up in the small town of Hubbardston in the snow belt of Massachusetts, not too far from the Quabbin Reservoir in the western part or the central part of the state. He holds a bachelor's degree in atmospheric science from the University of Massachusetts Lowell. He got his start with the National Weather Service in San Antonio as a NOAA Hollings Scholar, after which he moved on to Wilmington, North Carolina, their office, and served as the CoCoRaHS Regional Coordinator, the Fire Program Manager, and the Winter Weather Program Leader. Josh did a great job in helping bring the famed CoCoRaHS Cup to North Carolina during his time there. And in my opinion, he was the Johnny Appleseed for our program along the North Carolina and South Carolina coast, just spreading the information far and wide. In August 2018, he was promoted to the Weather Prediction Center as part of the winter weather team. When not working or monitoring extreme weather events from home, he has a variety of other hobbies. Some of those include competing in Spartan obstacle course races. He's an avid runner also. He also enjoys traveling the world and hiking in the mountains with his wife, Laura, also a Weather Prediction Center meteorologist. Additionally, Josh is one of the biggest Boston sports fans you will ever meet, and you can frequently find him cheering on his Red Sox, Celtics, and the Patriots. Well, Josh, thank you so much for being with us today. It's a pleasure to have you. I've got two quick questions for you as we begin. And the first one is, how did you become interested in weather? And the second one, I want you to tell us a little bit about how the CoCoRaHS Cup played a role in meeting your wife, Laura. So take it away.
Sure. Thank you, Henry. And thank you, everybody, for joining us today. As far as that first question, I became interested in weather actually almost 28 years ago today, believe it or not. As a 7-year-old growing up in that central Massachusetts snow belt, we had a major nor'easter, December 11th and 12th of 1992. So like I said, almost exactly 28 years ago today. And that storm dropped over 30 inches of snow on my house. And I just found it amazing. Every kid loves snow, but to have an event like that at a young age, and it just really formed my interest in meteorology. And ever since then, I pursued the interest through high school and college and got my dream job now working for the Weather Service. So I was not that 7-year-old that ever wanted to say I wanted to play baseball or be a firefighter. I said meteorology from 7, and I've been fortunate enough to pursue that and working my dream job and my career at this phase of my life. So yes, 28 years ago and been able to follow through to the point that I'm at today. So very fortunate in that respect. So funny story about the CoCoRaHS Cup helping me meet my wife is, as Henry said, I was the regional coordinator for Southeast North Carolina when I was working down in Wilmington. And in that role, I helped North Carolina win the CoCoRaHS Cup. And if you're not familiar with that, go to the CoCoRaHS website. There's a lot of great information about the CoCoRaHS recruitment that we do every March. And after we won, the CoCoRaHS Cup goes to all the different weather forecast offices in North Carolina. And when I was bringing it up to the forecast office in Morehead City, my now wife was working up there. I never met her before. And this was back in 2013, I believe. And I just happened to meet her. We got along. We're friends for a couple of years after that, and led to where we are today. So I kind of say the CoCoRaHS Cup is like the modern day Match.com or something like that, because it helped me meet my wife and if I'd never been part of the CoCoRaHS program, probably never would have met her, as we had no other interactions professionally during our times at the different offices in North Carolina. So yeah, Henry, I guess I can thank Henry for pushing me to be part of CoCoRaHS, and now it led me to having a wonderful wife who's now also a meteorologist, as Henry said, at the Weather Prediction Center.
Well, we're glad we could help you out there, Josh.
Yes, very much so. So I guess, Henry, can I take it away from here?
It's all yours.
All right, let me
show your screen, and Noah can help you with that if you need a hand.
I think I can do it.
There we go. Looks good.
And is it in presentation mode, hopefully?
It is now. You're all set.
All right, perfect. Well, thank you again, everybody, for joining us today. Once again, my name is Josh Weiss, and I am a meteorologist working at the Weather Prediction Center as part of our winter team unit here in College Park, Maryland. But as Henry alluded to, I've been here since 2018. Before that, I spent almost a decade at the Weather Forecast Office in Wilmington, North Carolina. And you can see there's a picture of me down there in 2011 when I first met Henry, when he brought the famed CoCoRaHS Cup to my office. So I wasn't always a winter weather forecaster. As you can probably imagine, Southeast North Carolina doesn't get a whole lot of winter storms. But as a program lead down there, when we did, I was kind of in charge of that role down there. So fortunately, I was able to get promoted to the winter team here at WPC in 2018 and have been there ever since. So what we're going to talk about today is the Weather Prediction Center's Winter Weather Desk. And I call this digging out. And I say digging out because you're going to see a lot of terrible puns in this presentation, but I hope to make you laugh. I hope we're able to have some fun here for the next hour. And what we're going to talk about is the WPC Winter Weather Desk, what we do, what products we have, our mission, our goals, and some of the goals for the future. Now, I'm going to guess that many of you are not familiar with the WPC Winter Weather Desks. So hopefully after this presentation, you'll have a better understanding of how important, what an important role we serve providing the winter weather forecast. So just want to make sure that advance.
Yeah, you're good.
Okay. All right. So before I go into the winter weather desk specifically, I'm going to talk just a little bit about the Weather Prediction Center. My coworker Greg gave a presentation much more in depth on one of these CoCoRaHS talks earlier this year about the Weather Prediction Center as a whole, but I'm just going to do a couple of slides on our history to let us know how we get there before focusing almost exclusively on the winter weather desk. So the first question here, what is NCEP WPC? NCEP stands for the National Centers for Environmental Prediction, of which the Weather Prediction Center, WPC, is one of the branches beneath that envelope of NCEP. And that's our building there in College Park. It's a green building, a beautiful building in College Park, Maryland. And we're going to talk a little bit about how we got to where we are today. So the Weather Prediction Center hasn't always been the Weather Prediction Center. In fact, it started back in 1942 as the analysis center of the Forecast Operations Branch of the National Weather Bureau, and that was located in Washington, D.C. And the purpose of this first demonstration of the Weather Prediction Center was to provide meteorological services for the War Department in 1942. And our primary mission was to produce CONUS there, that's the lower 48 of the United States, I'll use that term a lot, was to produce analyses and forecast products from 1 to 3 days just for the lower 48 states. In 1958, we merged with the Joint Numerical Weather Prediction Unit and moved from Washington, D.C. to Suitland, Maryland. And we got renamed at that point to the National Meteorological Center, NMC. And now you clearly realize that that's a weather department, whereas analysis center was a little bit tough to understand what we were doing. Something very important happened in 1970 when NOAA was created. And if you're not familiar with NOAA, that's the National Oceanic and Atmospheric Administration, but as I like to call it, because we use so many acronyms, the National Organization for the Advancement of Acronyms. Either one is okay, but in 1970, NOAA was created, and the Weather Service, the National Weather Service, became a division of NOAA. So the Weather Bureau became the National Weather Service, a division of NOAA, where we still are today. Then in 1975, still as NMC, the National Meteorological Center, but now as a division of the Weather Service, we moved to Camp Springs, Maryland, into what we call the World Weather Building. And one thing I want to point out, when we made that move, there was one employee who was working there who actually just retired this week from the Weather Prediction Center. He was the only one who was left for when we moved to the World Weather Building. So he put his 50 years in, retired this week, and I just want to give him a little shout out because he had a great long career and was the only one left from that move in 1975. Then in 1995, the National Meteorological Center, NMC, was reorganized again, and this is how we got to NCEP, the National Centers for Environmental Prediction, of which HPC, you see Hydrometeorological Prediction Center, now WPC, is a subunit. And I mentioned that WPC is one of the many branches beneath NCEP, and these include a bunch of different acronyms here, from left to right, the Aviation Weather Center, the Climate Prediction Center, the Environment Modeling Center, the National Hurricane Center, the Ocean Prediction Center, the Storm Prediction Center, the Space Weather Prediction Center, and then the Central Operations Unit. And these are all different national centers beneath the envelope of NCEP. But of course, the one we're going to talk about today is WPC, and that is the Weather Prediction Center, which got renamed in 2013 because Hydrometeorological Prediction Center is very hard to say. So we became the Weather Prediction Center, and we were renamed in 2013. And that was shortly after we moved to our brand new building that I showed you the picture of earlier in 2012 in College Park. And sadly, if you look there on the bottom center of your screen, just this past March, the old World Weather Building was torn down. So that is the last lingering piece of the original World Weather Building of the Weather Prediction Center, the Hydrometeorological Prediction Center, torn down. And now we're all in our nice new building in College Park. So what is NCEP? What are the National Centers for Environmental Prediction? Well, basically what we do is we provide specialized overview with national level expertise. And what does that really mean? I think the best way to look at it is like this. If you're living in Boston, Massachusetts, for example, you might get on a bad winter 7 or 8 or 9 bad winter storms. And then that's what the forecasters work with. You get a couple of storms every year, and then you move on and you don't use that knowledge for the next 6 months until winter comes back. Well, at the National Center, we are responsible for handling the meteorology and the forecasting for every winter event that occurs across the country. So while an office or an area like Boston might get 7 or 8 storms that they forecast for every year, at the National Center, we might have 40 or 50 because we also worry about the storms in Colorado. We also worry about the storms in Washington State. We also worry about the storms in the Great Lakes. So we cover every winter event that happens across the year. And because we are so involved in depth with all these different winter events, we develop that expertise over time. We improve the modeling and we develop that expertise to recognize these winter storms and how they're going to evolve. And that's where we provide that expertise. Even though we're not specifically local to any given area, because we're involved with every winter storm, we develop that talent over the time. And our primary mission then is to assist with the WFOs, the weather forecast offices, your local National Weather Service offices, in their decision making and their forecasts and analyses for these winter storms from the winter desk. Of course, WPC does have other desks. We have 9 desks staffed at any given time. It includes 32 forecasters and approximately 50 total staff. And we have a variety of different products and services that we produce, including what we're probably most known for is our rainfall forecasts. So we cover a large domain as well. What you see there in the red box, that's our CONUS, that's our lower 48. And for the winter forecast, I put a little bullet there. That is the only area for which we're responsible. So we cover the lower 48 for our winter forecast. For some of our other products though, we also include Alaska and Hawaii. We have rainfall statements for the entire Northern Atlantic Basin and the Eastern Pacific Basin, which we coordinate with the National Hurricane Center. And we also have something very interesting, the International Desk, which actually will train forecasters who come and do rotations with us from Central and South America and the Caribbean as well. So the last slide here about just general overview of WPC. This is our mission. You can read that there at the top. But again, our primary responsibility is to aid in the decision making from the forecast offices for those local forecast products that you all see. I'm not going to cover everything on this slide. We do have kind of 3 ranges of routine products. One are the analyses there on the left in the blue, and this includes your surface analysis or your storm summaries about any big event that might happen. Where we spend most of our time is in the short range, days 1 to 3 or 6 to 84 hour forecasts. And this is where winter weather spends most of its time. You can see some of the other products there, but this is the meat of WPC is in that days 1 to 3 time range. But we also have the medium range, which is our days 3 to 8 forecast or 72 to 204 hours. And we produce pressures, fronts, temperatures, and QPF, which is our rainfall, even out through days 7 and 8. And as we're getting better, our models are getting better, our skills getting better, this is where the decision making becomes more and more important. So the Weather Prediction Center is always trying to expand our ability to forecast out further in time so that people can be prepared for upcoming weather events. So with that, there's kind of a brief background of WPC. We're going to spend the next 45 minutes about the Winter Weather Desk specifically. And you see here on the right-hand side, there's Luke Skywalker on a tauntaun in the planet Hoth. This is winter, and I'm a Star Wars fan. So I just want to preface this by saying there's going to be a lot of bad Star Wars puns, but I do want to hopefully get some laughter and keep you guys entertained today. So the Winter Weather Desk, as Henry alluded to earlier, it is generally staffed between late September and early May. And that's in the United States, that's when our winter season is. We have 4 forecasters who are on a rotation. I'm one of those 4. And while we're typically only staffed the desk between September and May, we are available for support for early or late season events. In fact, just this year in September, we had an event that affected Colorado with a lot of snowfall, and we did spin up the desk. We were able to provide support. And then middle of May in New England, we had an event. The desk was not staffed anymore, but we provided support for that as well. So while we're only staffed about 8 or 9 months a year, we are able to support out of season events. So how did we get to this point? Well, I want to talk a little bit about the history of how the Winter Weather Desk became to where it is now at WPC. Well, before 1999, which I don't have on this slide, but before 1999, HPC, now WPC, was producing just deterministic forecasts for the populated areas of the eastern United States. And there are 2 words I'm going to use a lot in this presentation: deterministic and probabilistic. Deterministic is the actual snowfall forecast. That would be saying 4 inches of snow, 2 inches of snow, 10 inches of snow. The probabilistic forecast is kind of your certainty or the probability or the chance of reaching a certain level. So while a deterministic forecast might say 4 inches of snow, the probabilistic forecast would say a 75% chance of 4 inches of snow. So just keep that in mind as I go through this, because I will use those words a lot. They're not interchangeable, but they're very related. So before 1999, we were just producing deterministic snowfall forecasts for some of the populated areas of the eastern United States. But then beginning in 1999 and through 2001, it began to change a little bit, and we produced deterministic snow forecasts, and I should say the ice forecast as well for freezing rain. But we also started producing categorical probabilities for the snow and ice amount. And you can see an example of that on the right-hand side, one of these images here. This is one of our early probabilistic forecasts for 4 inches of snow here. And you can see the confidence levels: low, moderate, and high chances for snow, low, moderate, and high chances for freezing rain for an event that affected the Mid-Atlantic and the Northeast. And this was a change in WPC or HPC policy at that point. We started to produce these probabilistic forecasts trending in that direction. Now, these initial forecasts were just for a small region of the Mid-Atlantic for these 4 forecast offices: State College, Sterling, Wakefield, Virginia, and Mount Holly, Philadelphia. And if you're not familiar with this map here, this is a map of the United States, or the Mid-Atlantic of the United States. And these little call signs are the different WFO, weather forecast offices, areas of responsibility. So for example, when you look at this LWX, that's Sterling, Virginia, they're responsible for producing the local forecast for much of Maryland and Northern Virginia. So while you can see the states here, that's what these call signs are. And at that initial time, we were only producing these probabilistic forecasts for those 4 CWAs up through 2001. But beginning in 2001, we wanted to expand this. The WPC management worked with the weather forecast offices and National Weather Service headquarters to determine how WPC can best assist in these winter forecasts, improve our consistency, improve our coordination. And there was some motivation for this. You can see over here on the right-hand side, there were a couple of winter storms during the seasons of 2000 and 2001 that were less than stellar forecasts, I guess would be the best way to put it. And one that a lot of people remember was the March 4th to 6th, 2001 event, where I think New York City was forecast to get more than 20 inches of snow, and they mostly got rain. So there were some less than stellar forecasts, maybe some missed events that led to the development of trying to figure out how to improve this forecast. So not just improve the forecast, but produce a consistent forecast as well across the nation. So again, I have a Star Wars pun here. Instead of Princess Leia asking Obi-Wan for help, it's "Help me, WPC, you're my only hope." And that was the National Weather Service headquarters saying we need to improve our consistent messaging here. So the decision was made to start a winter weather experiment, the first winter weather experiment from WPC, where we would produce some enhanced forecasts, which I'm going to show in the next couple of slides, to the Weather Service offices and through the public to improve the coordination of winter storm watches and warnings. So as I touched upon, for the next 3 seasons, 2001 to 2004, we had this first winter weather experiment. And this is what it consisted of. We now were producing the probability of 4, 8, and 12 inches of snow, along with that deterministic snow forecast, and the probability of a 1/4 inch of ice and that deterministic ice forecast. So if you remember, with that initial 1999 to 2001, we were just doing the categorical probabilities of 4 inches. Now we were doing 4, 8, and 12. And of course, a forecast is only as good as the verification. So we were going to verify these over time to see how they evolve. And some of the metrics that we used were the probability of detection, or POD. And what that is that if I issue a winter storm warning, does it verify? Do we get heavy snow and impacts? The false alarm rate, or the FAR, that would be if I had to issue a winter storm warning, does it not verify? That would be a missed event. The critical success index, the CSI, that's our numerical verification of how we're doing. And then of course the lead time, how much in advance did we produce these forecasts that verify? So we would use all these different metrics to determine how we were doing over the next 3 seasons. Now, I know there's a lot on this slide. You don't have to pay attention to all of it, but these were the results of those 3 seasons. And what I want to point out the most are 2 things. At the bottom here, you see how this evolved with time. In 2001, there were only 8 WFOs. And again, WFO is the Weather Forecast Office, those local weather forecast offices I mentioned a few slides ago. And that was generally just the I-95 corridor between Washington, D.C. and Maine. In 2002, that expanded to most of our Eastern region forecast offices and then expanded into some of the Great Lakes offices, so 31 WFOs now involved. By 2003, it expanded to 77 WFOs. Now, roughly 2/3 of the country was involved in this experiment. And by 2004, all of the WFOs across the country were involved, or the lower 48 were involved with this experiment. The other thing I want to point out is you look at these PODs, so this is for Eastern region, Central region, Western region, and Southern region. The PODs generally from left to right improved each season. And the POD, again, the probability of detection, if I issue a winter storm watch or warning, does it verify? And you can see that these scores generally improve with time. So that suggested that what we were doing was working, and that was a good sign for the experiment. So because everything was going well, in September 15, 2004, the Winter Weather Desk was no longer experimental. It became operational, producing these deterministic and probabilistic forecasts. And so the guide of the Winter Weather Desk was to produce probabilistic and deterministic expertise for all heavy snow and icing events across the CONUS. And here's the Emperor saying, now witness the power of this fully operational Winter Weather Desk. Not as scary as the Death Star, but something nonetheless for the Emperor to be proud of. So before we move on, I want to talk a little bit about what products we do create. Excuse me. So the Winter Weather Desk produces a variety of products, and I'm going to show you what we produce. But there's a caveat to this that I need to mention in the beginning. Our deterministic snow and ice forecasts are internal only to the National Weather Service. So if you're a general public person, you want to see some of our forecasts, or you're a media, you're a CoCoRaHS observer, if you're not within the Weather Service, you cannot see our actual deterministic snow and ice forecast. But that doesn't mean that they're not important to you. And the reason I say that is because the Weather Service, the weather forecast offices, will take our internal information and use that to help produce their public forecast products that go out to everybody. So while you might not be able to actually see how much snow WPC may be forecasting for an event, know that that information is being used by the weather forecast offices to produce their snow and ice forecast and their winter weather hazards and their forecasts that go out to everybody. So that's important to know. So the first couple of slides are going to be internal products. I still want to show you what we do and how we create it, but you can actually see those products. But as we go through the other bullets, you will see that most of these are public facing and it's stuff that everybody can use and examine. So our deterministic snow and ice, this is a little bit about what it's going to look like, and then the next several slides will actually show you how it's done. Before 2009, our WWD, and that's our Winter Weather Desk graphics, I just call it WWD, was created through NAWPS. And I doubt many of you know what that stands for, but it's the National Center Advanced Weather Interactive Processing System. There's no quiz on that at the end, so don't worry. But before 2019, we were using NAWPS. Notice in 2019 to 2020, that changed to AWPS. So we lost the N, and now it's the Advanced Weather Interactive Processing System. And you see I have GFE there in parentheses, and that's our graphical forecast editor. And all these really mean is that this is our computer software that we use to create our forecast. And I'm going to actually show you a little bit about how this works. But the change was made for 2019, 2020, and again this season, for a variety of reasons. But the 3 most important, that had better resolution. So in NAWPS, we were working roughly 40-kilometer resolution across the country, and now we're in 5-kilometer resolution. This leads to better verification, including improved forecast skill scores, because with snowfall, it can vary so much just in the course of a couple miles that better resolution can create a better forecast. But it's also, and maybe the most important, it's easier to now assist the WFOs, and that's the weather forecast offices. And the reason I say that is because the WFOs are also in AWPS. They were never in NAWPS. So when we're comparing our information and comparing our forecasts, it's now apples to apples versus apples to oranges, which made it a little more challenging in the NAWPS world. So when we produce our snow and ice forecast, this is the equations that we use. And again, no quiz at the end, so don't worry. But you'll see there for snow, it's QPF times POT times SLR. And the QPF is the Quantitative Precipitation Forecast. That is our rainfall forecast that WPC produces every day. The POT is our probability of weather type. That's the chance of snow, sleet, freezing rain, or rain at every grid point across the country. And our SLR is a snow liquid ratio, basically how much snow will fall from every inch of rain. And you see for ice, it's very similar, but we use ILR, which is ice liquid ratio. Same idea, but for ice accretion or freezing rain accretion versus snow. We're going to go over this a little more in depth now. So for snow, again, we see that equation, pot times QPF times SLR. And I'm not going to talk about QPF, that's our rainfall. You can see Greg's presentation from several months ago if you're more interested. But we do produce rainfall every day from WPC, and that goes into the winter forecast. So the first thing I'm going to cover is our POT, our probability of weather type. And what is that? What is the probability of weather type? That is just a chance at any grid point across the country of these 5-kilometer grid points of there being sleet, freezing rain, snow, or rain. And we use what we call a decision tree algorithm. It's kind of a simple algorithm that's developed by WPC. And what it does, it determines one precip type for each grid across the country. And notice there are almost 1 million 5-kilometer grid points that we use in our forecast. And what it does, it looks at the thermal structure. So it looks at the different temperatures at these different levels. So you have our surface, which is at the ground, 925 millibars, about 1,500 feet up in the sky, 850 millibars, about 5,000 feet up in the sky, and 700 millibars, about 10,000 feet up in the sky. And you can see here our flow chart that it looks at. And you don't need to understand all of this, but just know that it looks at these different levels, compares the temperature, and it decides if it should be freezing rain, sleet, snow, or rain based off the thermal structure. And this is done for every grid point across the country. So this decision tree algorithm determines our precip type, which is then given in a percentage, which I'm going to show you now. So on the right-hand side, this is what the probability of weather type for snow at a 6-hour interval might look like. And this is our graphical forecast editor. So this is our GFE. This is what we're actually working in. And you can see, values there that vary from 10 to 100. Now, in this case, if you see 100, that means that it's 100% chance of snow from whatever model we're using. See a 10, it means it's 10% chance for snow, which means that one of the other weather types, probably rain or freezing rain, would be much higher because everything adds up to 100. Now, these grids, and I call these grids in GFE as a graphical forecast setup, but these grids, probably should have made that clear. They're initialized using a procedure with a first guess, which is based off the European model and the European ensemble model. And if you're not familiar with an ensemble, what an ensemble is, it takes a model, it changes the initial conditions a little bit, and it runs it a bunch of times to produce a variety of forecast scenarios. For the European, they run that 50 times. We get 50 different solutions, and this allows us to cover all the ranges of possibilities that may occur for an event. So for our pot weather, we're running that 50 times using that decision tree, and this is what we come up with. And while we initialize with the European ensemble every day, this is forecaster editable, and the forecaster should use their expertise to produce targeted changes and improvements based off model preferences. Maybe the European's a little too cold, or one of our other models might be too fast. We use this information to adjust the probability of weather type to improve our forecast. And then once that's all done, we normalize everything to 100 because we don't want anything for 150% of snow. That wouldn't make any sense, and we are scientists. So once the pot grids are done, as you just saw, so we do that for snow, freezing rain, sleet, and rain for 72 hours in 6-hour increments. We also have to produce our snow liquid ratio. So before 2019, the snow liquid ratio was produced using our legacy blend, which consisted of 5 different models that were blended together to produce our SLR. But unfortunately, when we were doing some of our verification, again, I said the forecast is only as good as the verification. Before that, we found that the verification was not very good for these SLRs. So here's Obi-Wan saying that these are not the SLRs you're looking for, instead of the droids. Again, really terrible Star Wars pun. So after 2019, we changed this. We went to a modified version of the National Blend of Models. And if you're not familiar with the National Blend of Models of the NBM, that's a new change to the Weather Service over the last couple of years, and is shown to be a very effective blend of models that are initializing in a lot of our forecast offices these days. So we started with that, and what we do is we take the output from the NBM snow liquid ratio, we multiply it by about 10%. You can see the 1.13 times the NBM. And we've shown that to be verifying quite well, just a little bit better than the NBM is showing. So that's how we initialize our SLRs every day. But again, using forecaster expertise, we can raise or lower these SLRs. If, a Great Lakes event, you might have a snow liquid ratio of 30 inches of snow for 1 inch of rain. And we would raise that in that case. So if there's a significant snow band producing 2 inches of snow per hour, we might raise the SLRs in that case. Or in the Pacific Northwest, a lot of times, we lower the SLR because it's just so wet out there that the guidance is over predicting the SLRs, the snow liquid ratios. So forecaster intervention is needed in all of these fields, even though we are initializing with certain computer models. So once that's all done, we produced a forecast. So these next 4 slides are going to show you exactly how that looks very quickly through our GFE. So here's our rainfall. You can just see for the western 2/3 of the country, here's an example of rainfall that we get into our GFE. We move forward, here's an example for that same event, our probability of snow, and notice very high in the mountains of Wyoming into Montana and Idaho, with some lower amounts into the high plains of Nebraska and North Dakota, South Dakota. Here's our SLRs for those days. See very high SLRs, 15 inches of snow to 1 inch of rain there in maybe the bighorns of Wyoming and towards the Teton ranges, but lower as you head into the high plains. And you put this all together using our equation, and you get a snowfall forecast. Excuse me. You get a snowfall forecast, and this is what it would look like in our GFE. You can see some pretty high numbers there along the Front Range of Colorado, towards the Cheyenne Ridge of Wyoming. But this is what we would see, and this is what the forecast offices would see. And when we finish up, here's Babu Frick telling everybody that the WWD is ready. He's taking a break from his droid fixing to tell everybody the WWD is now ready. And we will send this to the WFOs, to the forecast offices through their AWIP systems, which they can then look at. So that was just a small area, but we produced 3 days of snowfall across the entire country. So here's just an example of how this looks. This is a 3-day storm total for the entire country. Notice we've got a variety of different winter events going on. Remember I said in the very beginning, a forecast office might only deal with 5 or 6 or 7 snow events in a year, but at WPC, we deal with all of them. It could be 40 or 50 across the season. So in this case, just specifically, we have an event going on off the Great Lakes in upstate New York. We've got a big snow event in the Intermountain West and the Northern Rockies. And it looks like another event coming into the Pacific Northwest and the Cascades of Washington and Oregon. So 3 events just in this image, but this is just to show you what it looks like on the national scale. So lastly, producing our deterministic ice forecast follows the exact same process, but the difference is in the ILR, the ice liquid ratio. In the ice liquid ratio, we use what we call a freezing rain accumulation model, which was developed by a paper written in 2006, which it takes into account a variety of different parameters to produce the freezing rain rate. And what it looks at surface temperature, it looks at the wind speed, it looks at dew point, it looks at the precipitation rate, and using all of those together, it produces what it thinks will be the ice liquid ratio. So for example, if you get an inch of liquid rain, how much freezing rain will come of that? Usually it isn't 1 to 1, it's definitely not 10 to 1. A lot of times it could be like 0.7 to 1, between 0.7 and 1.2 to 1. So other than that difference, the creation for the winter, the freezing rain is exactly the same as snowfall. So I'm not going to show you what that looks like on the national scale because you just saw it, but just envision it looks very similar, but it's for freezing rain instead. And we again send that to the forecast offices once it's done. So in addition to sending it through our graphical forecast editor AWIPS, we also have an internal web page. Again, you guys, most of you can't see this is just internal. But this is another way for the forecast offices to see our snow and ice forecast. And this is nice in case AWIPS is malfunctioning for whatever reason, but also allows you to separate into 12-hour increments. You can see here in the pink circle, 12-hour increments, and also the previous and the most recent model runs, or the previous and most recent forecast from WPC. So you can watch the trends. Trends of snow and ice are very important in forecasting. So they will use this page a lot to see how things have changed and what we are forecasting to compare to their thoughts. So that's the deterministic snow and ice, but now we're going to move on to the probabilistic. And again, the probabilistic basically just means the chance of reaching a certain threshold. And our probabilistic information is available to everyone, but I'm going to start by showing two examples of things that are still internal before we move into all the probabilistic information that's available to the public. So this is just an example of some of our products that we have, and I'm going to talk about each one of these individually. You can see there's a variety of different probabilistic products that we produce that are very exciting and new and up and coming for the Weather Service. So why do we use probabilistic winter forecasts? Well, for one, it allows us to leverage all the models using an ensemble approach. And again, if you remember what ensemble is, change the initial conditions a little bit, get a variety of different outcomes. It allows us to see all the possible forecasts for a single model, but every model has its ensemble. So the European has 50, the GFS, another model, the Global Forecast System has 30, the Canadian model has 20. We've got about 103 different ensemble members that we look at every day that we run this probabilistic for. Using the probabilistic approach allows us to account for outliers and high-end event potential. So while you may have 70 models suggesting 4 inches of snow, you might have 30 suggesting 10, and that's important to know, which you wouldn't get if you didn't have the ensemble approach. This provides a reasonable worst case forecast for decision makers. So maybe most of the models are showing 4 to 6 inches of snow or forecasting 4 to 6 inches of snow, but there's a chance that some places could get 10. And that could be a big impact for the Department of Transportation, for example, their road clearing equipment. So all important to know these reasonable worst cases that show up in these ensemble forecasts. It'll encompass more solutions and reduce the potential of a missed event or a challenging forecast. Remember, the winter weather experiment that we had in 2001 was somewhat motivated by some challenging forecast issues we had the previous season. So just there at the bottom, some of the products that we're going to cover. These first two, the winter storm ensemble and its plumes, those are internal, but everything else will be external to the public, and we'll go over all of these. So first, the winter storm ensemble, the WSE, that is our in-house, WPC's in-house ensemble. And it has 63 members in total, and it includes what you see here, 25 of the Europeans, so half of the European members, 10 of the GEFS members, 10 of the Canadian members, 10 high-res members, and all of our deterministic forecasts. And again, the ensemble members are just the same model with a slightly different change in the initial conditions. So this, and on the right-hand side, you see what this looks like. And this allows forecasters to see the range of possibilities. That's the benefit of the ensemble approach, of the probabilistic approach. And in this case, using this method, forecasters can see the spatial changes of the different model ones. So in this case, you see there's potentially some heavy snow here in Alberta, Canada, into Montana, but the next model might be further east, one of the other models might be further west. It's just a screenshot, but allows us to see the confidence in the spatial distribution of the snow and ice forecast. But again, this is internal only to the weather forecast offices, but I put that in there, but I want to note that the weather forecast offices will use this for their public-facing products. So the winter storm ensemble also produces these plumes that we call them, and that's what you're seeing here on the right-hand side, these winter storm ensemble plumes. This takes our 63 members again, and this shows the evolution of the rain or the snow or the ice for a single point. So you could choose Albany, New York, for example, and see how all the different members are showing different snow and ice forecasts. So what you're looking at here on the right-hand side is one of those plumes. The black line is the mean of all 63 members. And you see a lot of them might be clustered here between 3 and 8 inches. That's suggesting, maybe a 4 to 8 inch snowfall forecast. But notice there are some high-end numbers here, 10, 12, 14 inches. And that is what we wouldn't see without this ensemble, this probabilistic approach. So this, again, allows forecasters to see the range of possibilities. Now, typically, we want to focus on that clustering. Like I said, and that's where most of the models think that the forecast is going to hinge upon, where it's going to fall. But this also allows us to estimate the percentiles. Maybe we want to know the 90th percentile, and we'll use that for our decision makers. It's 4 to 6 inches, but there's 10% chance of exceeding 10 inches. Something like that's very important. It also allows us to show the outliers. If you have a bunch of models that are showing 10 inches, that would be an interesting percentile to examine. But if you just have one model showing 10 inches and everything else is 2, it's more likely that's an outlier, not something that really needs to be considered. The other thing that's important with these plumes, up here, we have the d prog dt of the mean. So what that means is just a trend of the mean of the ensemble. This black line changes with every run that runs every 12 hours. And you can see in this case, the blue to the red to the pink to the green, the trend has been upward with the last 4 runs of this ensemble. So that tells us that in general, for this specific event, our snowfall forecast is trending upward, and that's something to consider for our forecast. This is really important and used a lot to guide our messaging for our decision support services to emergency managers, to our partners, and to get the information out to the public for their forecast. So that covers all the internal information that we have, and now we're going to get into the public-facing products. So this first one is the Probabilistic Winter Precipitation Forecast Viewer. That's a mouthful. We're going to go with another acronym, PWPF. Again, NOAA loves their acronyms, but just easier to remember, PWPF. This is available. You can see the website is listed down there at the bottom, but I will note also that all the links that I'm going to show will be included on the WeatherTalk page that NOAA and Henry will be putting together after this presentation. So you can go and you can look at all these websites afterwards. You don't need to write that down if you don't want to. This is our first public-facing probabilistic product. And what this shows you is the probability and percentile of exceeding snowfall or ice at different thresholds, either 6, 24, 48, or 72-hour intervals. And you can see on the right-hand side here, you can look at for snow, 1, 2, 4, 8, all the way up to 18 inches of snow for these different time ranges. So you can go in there, you can mess around, and what this does, it allows you to see the confidence, the spatial confidence of certain exceedance probabilities. So just in this example, you can see for 1 inch of snow, greater than 80% chance here in the Tetons of Northwest Wyoming, probably going to get more than 1 inch of snow. But here in the Bighorn Range, only about a 30% chance may not get an inch of snow. And this is important information for us as forecasters to consider, especially when we're trying to message those reasonable worst case scenarios. So you can go in, you can look at this webpage, you can kind of get a feel for how much snow might fall in your backyard using this webpage. And again, this helps with forecast confidence, but also used to message these best and worst case scenarios for the decision makers and into our public facing forecasts. So something that's pretty new from WPC only over the last 2 years is the Winter Storm Outlook. And this is another probabilistic product, but the key difference between the Winter Storm Outlook and the PWPF you just saw, that instead of showing the probability of exceeding a certain amount of snow, like 4 inches, this is showing you the probability of exceeding a locally defined winter storm warning threshold. Now that might not make any sense, but I bet a lot of you didn't know that the Weather Service actually has defined winter storm warning criteria for snow and ice across the country. And that's what you're seeing here in the bottom 2 images. On the right-hand side, this is the 24-hour snow that is required for significant enough impacts for winter storm warning across the country. You see it varies. I think this is 1 inch or half an inch down in southern Florida, all the way up to 10 inches in northern Maine and parts of Michigan. So if you're only getting 6 inches of snow in Maine, that's not going to require winter storm warning. 6 inches of snow in southern Florida would certainly require winter storm warning. So just to give you an example of what you're looking at. Over here for freezing rain, generally a 1/4 inch of freezing rain across most of the country. There are some lower and higher thresholds, New England 1/2 inch. But notice it does vary regionally across the country and with a lot of the terrain in the West. And what the WSO does, the Winter Storm Outlook, it knows all those thresholds, and it looks at our winter storm ensemble that I just showed you, and it tells us the probability of exceeding the thresholds based off the local criteria. So in this case, this was an event we had over Montana and Idaho. You can see a lot of areas in the terrain, especially greater than 80% chance of exceeding winter storm criteria for snow, but even 50% chance into some of the foothills as well. So this is what we look at, and all this is telling us is based off that winter storm ensemble, the probability of exceeding these locally defined thresholds. So if you think about it, if you have a 50% chance of exceeding threshold, and you have 63 members in our ensemble, that means about 30 members from our ensemble are suggesting that winter storm criteria will be exceeded in these areas where you have 50%. So that's how you want to interpret this information. And this is available to everybody. Again, I'm going to actually put the link on a subsequent slide, but it will be available on our WeatherTalk page after this presentation. So the WSO is available in 2 different ways. It's available in our GFE that you can see there on the top right. That's for the internal, for the Weather Service offices, internal viewing, but also the web page that I'm going to show on the next slide, which is new. The web page is actually new for this season. It's the first time that we've made this data available to the public because we think it works very well. And I will show that again on the next slide. But the purpose of the WSO is to aid the weather forecast offices. So the WSO aids the WFO. Now, it's kind of hard to say. And the watch warning decisions, because generally, if you have a 50% chance of exceeding criteria, you want a winter storm watch or warning out. So, in these areas here in Nebraska and South Dakota for this event, you have a lot of areas of 50% chance of exceedance. You would probably want a winter storm watch or winter storm warning. So here's C3PO telling us the possibility of warning criteria is as low as 2 to 1, 50%, a little bit better than Han Solo surviving the asteroid belt. And here is that WSO website. And I'm not going to talk too much about what's on there, but I highly recommend everybody go check it out. And one of the things that I do want to point out there in the red arrow at the top, I have a link. We have a link to providing some feedback for the website. So please, if you do go take a look at this, which I highly recommend, mess around with it. The map is zoomable, it's clickable. You can create some static images at the bottom you see there to save some PNG files, whatever you want to do. It has a lot of different backgrounds. If you do go look at this for yourself or for your friends or want to see what the weather forecast offices are using for the probability of warning criteria snow, please provide some feedback. We're always looking to improve and change it based off that feedback. So very important if you look at it to send us an email using that link at the top. So another probabilistic product that we use is the Winter Weather Outlook. So we have the WSO, the Winter Storm Outlook, which is days 1 to 4, probability of exceeding that locally defined winter storm warning criteria. Now we have the Winter Weather Outlook, which is days 4 to 7, but this goes back to just a generic probability of exceeding a value. So the Winter Weather Outlook is the medium range, days 4 to 7. As I said in the very beginning, we're trying to expand our lead time on these things because a significant winter storm on days 4 and 5 needs to be addressed. So we have the Winter Weather Outlook, and what that does, it gives you the probability of exceeding a 1/4 inch of liquid, but that liquid falling as snow or sleet. So So generally 0.25 inches of liquid would be about 2 to 4 inches of snow for a lot of events. So you can see in this image at the top, for this one, I forget what day this was, but this was day 5. You see there's a 70% chance here across parts of Montana for at least 2 to 4 inches of snow generally on day 5. And that's really a high probability that far out. This is a public facing product. You can see the webpage here. And how this works is that it takes our medium range quantitative precipitation forecast, the WPC rainfall, it applies all the ensembles that we've mentioned, and it produces the probability. So again, like I said, if it's 50%, then half the members are suggesting it. So 70% or 90% on day 5 means almost all the members are saying you're going to have an impactful winter storm, and that's how we would use this. And this is really used to help provide early messaging for significant winter storm potential. You wouldn't really be able to produce a deterministic forecast, say 8 to 10 inches of snow out of this, but you could start messaging the fact that a significant and impactful winter storm is likely days 4, 5, 6, whenever this may show up. And here's Maz Kanata, another one of my favorite Star Wars characters, very wise, telling us the forecast you seek is not behind you, it is in front of you. And that is true. We're going further out in time to try and improve the messaging and the response to these impactful winter storms. So another product that we have that's actually not live yet, but hopefully will be pretty soon, is a version of the Winter Weather Outlook. But instead of just looking at the probability of exceeding that 2 to 4 inches of snow or 0.25 inches of liquid falling in snow, it works just like that PWPF we saw earlier for days 1 to 3, but now it's for days 4 to 7. So this is in development right now. It's not available yet. One of our forecasters is actually working hard on this all the time. And this takes all the 103 members from the different ensembles and provides a PWPF, just like we saw for the different thresholds. So this goes from 1 to 24 inches of snow and also provides the percentiles. So while this isn't available yet, I do think it will be in the hopefully next couple of seasons. And this is going to be a big improvement because it's just like our PWPF that's so important in the short range, now providing better guidance and insight for the medium range. So one of the changes with the Weather Service over the last several seasons is to shift our products and hazards more towards impacts-based versus amount-based. So instead of saying 2 to 4 inches of snow, shifting towards how that will impact an area. 2 to 4 inches of snow in Buffalo, New York won't do a whole lot, but 2 to 4 inches of snow in Atlanta, Georgia may shut down the city. So important to understand that impacts can be more important. And this is also important to understand because we will have events that can be very impactful that don't reach criteria. So if the winter storm outlook is producing a 0% chance because the criteria might be 6 inches of snow, but you get 1 or 2 inches of snow in a very short period of time, that could be impactful. So we need to address this as well. I took a few examples of how this can be used and why this is so important. You see 4 examples here that I was just able to very quickly grab for 1 or 2 inches of snow that fell in a very short period of time during rush hour. And hopefully none of us have experienced this, but traffic slows to a crawl, you can get tremendous traffic jams, terrible accidents. These things happen with only an inch of snow falling at the wrong time if it's very heavy. And this will not be reflected by our probabilistic products to give an impactful event. You will really not have any idea based off those. So we have some other products here. Now, if you're in Hoff and you have AT-ATs attacking you, I don't know if any of these products will help, but I just want to show that can happen as well. Another different type of traffic jam. So one of the tools we have for this is our snowband probability tool, which is now 2 years old. This is our 2nd season using it. It's still a prototype, but I use it a lot personally on the desk. And what this does, and this is available to the public, you can see the website down there, and I showed you up here how to access it from our homepage under forecast tools, snowband probability forecast. What this does, it indicates the potential for a mesoscale snowband, and it's taken from the HREF. The HREF is a high resolution ensemble forecast system. A lot of our high-res models that do very well in about 36 to 48 hours and 24 hours out. This shows the intensity, so basically the snow rate for each of these members. And when you see a high probability of high rates, you get a high confidence that you're going to have snow rates that could be 2+ inches per hour, for example. This can be used to diagnose some of those intense snow rates that might cause these traffic incidents we just saw, but can also show for overperforming events. For example, you have a big winter storm, generally 6 to 8 inches of snow, but if one of these bands is showing up, you might be able to message, well, locally it could be a foot of snow, and that's something that we use here. So what you're looking at here on the bottom part of the screen, this is actually the web page, what it looks like, and you notice these numbers. These are liquid equivalent. So in this case, you have a couple of members in these dark greens showing 0.15. That's liquid equivalent falling of snow in 1 hour. So if you multiply by the average SLR, snow liquid ratio of 10 to 1, that'd be 1.5 inches per hour snow rates. Anything over 1 inch per hour is very significant. Once you get to 2 inches, that becomes, damaging snow rates. We use this in conjunction with the Storm Prediction Center HREF tool, and I don't show that here, but that's another tool that's available that will be linked on the Weather Talk page at the end of this. Those go hand in hand. They're just showing different types or different versions of probabilities of these intense snow rates that can help diagnose these less than criteria, but still impactful events. Maybe more importantly, one of our new products that just went operational this season is the Winter Storm Severity Index, or the WSSI. This has been developed by our development training branch at WPC. Primarily, Josh Katzman is the developer for this product. And like I said, this has gone live this year. This is operational. I'm going to show you the slide, the website in a minute, and you can look at it. But the goal of this is impacts-based hazards. It's the first tool that tries to analyze the impacts of an event versus telling us how much snow or what the wind speeds are going to be or what the temperatures are going to be. It tells us what we think the impacts are going to be. And that's very important for decision makers and our forecast products. What this does, it will summarize all these different weather impacts, these components you can see on the right-hand side, including snow amount, the amount of snow, snow load. If you have very heavy wet snow on power lines, that will be more impactful than a light, fluffy snow that will just blow around everywhere. Blowing snow, ground blizzard, a lot of different components are used in here. And this will help highlight areas of significantly impactful weather, regardless of how much snow or ice is falling. So that's very important to note. One of the reasons we're going towards impact-based is because you can't have these less than criteria events that cause major problems. And this is the first tool developed to try and forecast that with some skill and some significance. Now, I do note in the little call out there are some changes coming. There's currently a social science funded product to try and improve the language and the coloring here to make it a little bit more user-friendly or to more easily consumable. Right now, I think it's pretty good, but there is a study going on to try and improve this over the next season or two. So we'll see how these evolve. But otherwise, you will see that the forecast that I'm going to show you is not for amounts, but it's for impacts. You can see the colors here. It's going to see what it looks like. So this is that web page, and here's the link for it. But again, it will be on our Weather Talk page at the end. And you can see here at the WSSI webpage, it's days 1 through 3, or summation of days 1 through 3. You see the colors. So we had an event off Lake Erie not too long ago where you had some very heavy snow, or a foot of snow south of Lake Erie. And I probably should have zoomed in a little bit better on here, but you can see some of the reds there suggesting major impacts for 12 to 18 inches of snow or for this event. Now, from this single graphic, you can't tell what's causing the hazard. Remember, I showed you on the previous slide, there's a lot of different components that go into it. But on the website, you can choose the impact or the component that you want to look at. So maybe it's snow load, maybe it's snow amount, maybe it's blowing snow, whatever it is, you'll be able to pick that up on here. This is probably the total, so the worst impacts. But notice it's forecasting impacts, it's not forecasting anything else. You can't tell anything about how much snow is going to fall just from this. Just know that it could be very impactful. And this is a great new way to try and diagnose how these winter storms are going to affect people. We also have these static images you can grab at the bottom. Again, I highly recommend going to check out this webpage. And again, provide feedback. There's a feedback link at the top if you do. But have some fun with this, get used to it. It's now operational, and it's a really nice foray into impact-based forecasting. So a couple more products we produce. A little more simple here. We have our low tracks and our discussion. For every big event, WPC, the Winter Weather Desk, produces a graphic of our low tracks. You can see an example here. And what this does, it shows the forecast low track in the L's and the line, so that's the track, but also shows the ensembles, in which all these little points, the oranges, the browns, the pinks, the blues, showing you the range of possibilities of that surface low. So in this case, all these oranges suggest that some of the models saying the low could be in Kentucky, could be in Georgia, we think it's going to be here, same for all these other points. And that will help guide our confidence in the low track. If you ever lived through a nor'easter, or really any winter storm, the low track can make all the difference between rain, snow, or a slushy mess mix. So knowing the confidence in these low tracks can be very important. So we produce that for every big event, every significant winter event, that's across the entire country. We also produce a heavy snow discussion, excuse me, which is available on our website. And that outlines the reasoning, the meteorological and forecast reasoning for the areas of heavy snow across the entire country. So if you're interested, that's something we produce every day. That's also available on our website to read. The last product we create from the Winter Weather Desk are our key messages, and we coordinate these. And what are key messages? These are kind of like the who, what, where, when, and why of the winter event. So we do these for all large-scale impactful snow or ice events across the country, and we coordinate these with the other national centers, with the regional centers, and also with the forecast offices. And the point of this is to make sure that we have a coordinated, consistent message about the forecast, the amounts, and the impacts, so that we're kind of doing a one NWS is what we call it, one message, one forecast, so that somebody living in Minnesota for this event isn't getting a completely different forecast than somebody living in Eastern South Dakota. They should be very similar. That's why we produce these key messages for consistent messaging of the forecast. And we do distribute these via the internal distribution list, but also you can view them because we send them via our social media platforms. That's Twitter and Facebook. For all these key messages, we will send them out each day during an event. So moving on, we're getting close to the end of this presentation. I want to show a little bit about how we produce what we do. I talked a little bit about AWIPS and GFE, but a couple of other things I want to touch upon. We've seen all the products. You might be interested to know how we produce these products or how we do our coordination. I'm going to talk a little bit about that over the next few slides. So I did mention in the beginning about NAWIPS versus AWIPS. And again, the only difference was the National Center AWIPS was not being used by the forecast office's AWIPS, but now fortunately WPC has moved into the AWIPS world. And you can see on the left-hand side, this is the old NMAP or NAWIPS. It's got 40-kilometer resolution, and there was a lot of hand drawing of the snow contours. Now in GFE, it's 5-kilometer resolution, and it's all computer generated with forecaster intervention with almost 1 million grid points across the country. Notice how much higher resolution this is, picking up a lot of the terrain over the state of Wyoming for this event. And while NAWIPS and NMAP worked very well, it's like the old Weiss Yoda, we're all very excited about GFE. It's baby Yoda. Everybody's talking about it. It makes everything better, and everybody's excited. So while you can never forget about old Weiss Yoda, new baby Yoda is definitely the future at the Weather Prediction Center for the Winter Weather Desk. And what you see here at the bottom is just one of the tools that we use. I thought you might be interested to see. This is what we call our SCAVEC, and that allows us to blend our models. You can see how big that GUI is, that graphical interface is there. And that allows us to blend all of our different models that we have. So you probably can't read a lot of them, but you have European, GFS, Canadian, some of our high res, the North American model. All these different things are in there, and that allows us to change the weights and adjust the forecast to what we think is our best using our expertise. So another thing that's very important to the Winter Weather Desk is coordination. Our primary mission is to support the weather forecast offices with their public-facing forecast watch warning decisions. We do that a variety of different ways. One of the tried and true methods is direct phone calls. We might pick up the phone and call, for example, Grand Rapids, Michigan forecast office, or they might call us. That works great. However, there are 122 forecast offices across the country, and we might need to talk to several of them at once, and direct phone calls will just take way too much time during a big event, calling 5 or 6 or 7 or 10 different offices. So we have a variety of different methods to communicate with multiple offices. One down here at the bottom left is what we call our NWS chat. Excuse me. That is internal to the Weather Service, but that every forecast office has a room where you can chat with multiple forecasters and decision makers across that area. Maybe more importantly, over here on the right-hand side is our collaboration chat, our internal AWIPS collaboration chat, and every forecast office and national center is on that chat. So if I need to talk to all the New England offices, for example, I can send a quick chat, tag their offices using their call signs, and they will all see that chat. We can all talk to each other at the same time. So it's an efficient method of coordination. Now, we do coordination calls for significant events. We will actually have a meeting via telephone with a lot of the offices that are expected to be impacted by a significant event to ensure consistent messaging, get on the same page with our forecast amounts. And up until last year, we did that just via a conference line. But starting this year, we now use Google Meet, kind of like Zoom, but we use Google Meet, which is the same functionality as Zoom. And this allows us to not only see face-to-face with the people we're talking to, but we're also now able to share graphically some of the forecasts that we're looking at. It makes it much easier to communicate and coordinate these forecasts. So Google Meet has been a great advance in the coordination process. And from my experience with a couple of storms we've had so far this year, it just works so much better than a simple call on the phone. So one of the things that I've touched upon several times is that a forecast is only as good as its verification. And WPC, we do a ton of verification. And I'm not going to talk a lot about the internal verification, but do note that we have a development training branch, and most of their role is to verify and improve our forecast models. So we conduct verification both subjectively and objectively, and I'm going to talk about that on the next slide. This allows us to improve our pattern recognition and forecast skill as we get more used to seeing the same things repeat themselves. But maybe more importantly, it allows for improvements in the forecast tools. You can see some of the charts here on the right-hand side that I'm not going to talk about, but these are some of the development branch puts together to show how the models are doing. And this may allow us to tweak a model. It may actually allow us to remove a model. In fact, our winter storm ensemble changed this season because we found some of our models were performing so poorly last year, we didn't want them in the ensemble anymore, which we would not have known if we did not perform this verification. So we're constantly updating verification. In fact, I just got information yesterday about how our models are doing for the first 2 months of the winter season. So it's rapid, it's always changing, and it's always leading to improvement. Now, how we use, one of the most important things that we use for our verification is NORISC, which is the National Operational Hydrologic Remote Sensing Center. Again, no quiz, don't worry about remembering that, but this is a public-facing product that, again, will be on our webpage, and actually I realized I didn't put the link on here, but it will be on the WeatherTalk page at the end. And this is kind of the one-stop shop for the snowfall analysis, how much snow fell across the country every day. And this uses all of the reports, from local storm reports from the WFOs, our co-op reports, CoCoRaHS reports, for all you CoCoRaHS observers out there, go into this. And where we get rainfall, but we may not get a snow report, it looks at one of our high resolution rapid refresh, the HRRR thermal structure, to try and determine how much snow fell from our stage 4 rain analysis. But CoCoRaHS observers do get their information included in this. And we use this for a lot, for subjective verification. So I can go back and look just at the next day and kind of see if I got the highest areas correct, even if it wasn't perfect, or if I was too low some places, or the spatial distribution. Subjectively, I can see how my forecast did. We also do a lot of objective verification, looking at the grid data here. And this can be used to develop seasonal climatologies and departures. Now, I think NORISC has been around for 11 years, so we have a pretty good data set now. And one of the things that we have learned, actually just this past October, was the snowiest October across the lower 48 since NORISC was developed. So it's things like that that we can develop and kind of look back and see, well, it's been so active. Yeah, it's the snowiest October we've had in the 11 years of the NORISC database. So things like that we use for verification. But the goal is to always be improving at WPC. So just 3 more slides here, and then we can move on to questions. I talked about WPC always wanting to improve. And so we'll talk a little bit about the future of the Winter Weather Desk. And here's wise old Yoda again, can never get rid of him. Always in motion, the future is. His funny way of speaking there, and that's very true. The Winter Weather Desk has evolved tremendously over the last 20 years, and I think 20 years from now, it's gonna look vastly different. Hopefully improved, but different in the next 20 years as well, when I'm getting close to retirement at that point, I would guess. Some of the things that we're going to touch upon, how we're going to be changing winter storm watches, improved and updated model guidance, and maybe even more efficient coordination. I've said how Google Meet has been a great improvement to coordination, but there are other things we can do as well. We saw this box earlier on how we evolve for winter storm watches, from the outlooks to the watches. Now, if you remember, the way the WSO, the Winter Storm Outlook, works right now is that it informs the watch decisions. So for example, a weather forecast office might look at this, see where the 50% area is, and use that to help guide where they're going to put their watch. I use this example, this is that same Lake Erie example we saw at the WSSI. And in this case, the watches here in blue matched very closely to the red area, the 50%, because generally if you have 50% WSO, you want to watch up. So that was a great example of how this coordination works. WPC produces the WSO, the forecast office will use that as one of their tools to produce a watch. But potentially in the future, the WSO will be used to explicitly define the watch. So instead of there being some subjectivity from place to place where the watches might be, we'll use that as a first guess and actually create the watch from the WSO with some adjustments possible based on forecaster knowledge. But that would improve overall coordination. It would limit the potential for messaging discrepancies across the country. Lastly, I talked a little bit about improved guidance and coordination. I mentioned the NBM several times in this presentation, the National Blend of Models. That has been a big improvement, especially for our SLRs, but that's constantly being improved. The developers are working on that annually with some input from the forecasters and around the field, around the rest of the country from WPC and WFOs. So that NBM is constantly being improved, and it's only going to get better. And as that calibrates better, our SLRs will get better, our QPF will get better, our snowfall and ice forecasts will get better. One of the other things that will be very important is extended high-res guidance. Now, our high-res models, which are generally run at 4 kilometers or so for some of them versus 20 kilometers for our global models, they give us a better output overall. They can pick up on terrain, they can pick up on some of these snow bands, but they're usually only run out for 24, 36 hours due to computing power. So day 1.5, maybe day 2. Just recently, the HRRR, the high resolution rapid refresh, was extended to 48 hours, actually just earlier this week. So that's been a big improvement. And some of these other models, there's plans in place over the next couple of years to extend these out to days 3 and 4, which will really improve our verification and make our forecast better. And one other thing here that would improve our coordination and make things a little bit better is ISC. And I know most of you won't know what that is. It calls for intersite coordination. That's in our GFE. Right now, when I finish my deterministic forecast and I send it to the forecast offices, it takes about 20 minutes for them to actually see what I've produced. if we're able to utilize this ISC in the future, as soon as I click save, the WFOs will get it almost immediately. So that's 20 minutes of time where we can do more coordination, more efficient coordination. So hopefully in the future, we'll have our WWD making it so the WFOs faster than the Millennium Falcon made the Kessel run in 12 parsecs. So that's all I have. And I know I was told I was going to get some flack for finishing this presentation with the scene from episode 1, which is nobody's favorite Star Wars. But they had the globe of peace there at the end of episode 1. So here's the globe of WPC's Winter Weather Desk with some of our products there being held by Boss Nas there. And I really appreciate you listening to me today. I know we covered a lot of material. I'm sure a lot of it is new. But with that, I will pass it back to Henry and take questions. And I thank you for joining us today.
Josh, thank you very much. Very, very interesting presentation. Lot to absorb, but again, we'll have the slides up there for you guys to go back over and on our website, and those links hopefully later today or early tomorrow. And again, this presentation is being recorded. So why don't we open it up now to folks out there. If you have a question for Josh, if you would type in your name and the state you're in, and then we'll take the question. And I think we have Nolan Duskin on with us. Nolan, do you have a question for Josh at all? Nolan's our founder of CoCoRaHS, and he was here in the background. Okay, well, the one question, James from Illinois says he takes it you're a Star Wars fan, and I guess that's a pretty accurate assessment there.
Yeah, what gave that away?
I'm not sure. I didn't see any references in the slides at all. So I'm not sure, maybe just your accent or what would have helped with that.
I've always liked Star Wars, but it's funny because I participated in a winter weather experiment about 2 seasons ago, I think, at WPC, just an internal experiment, gave a presentation, and I saw a lot of parallels between some of the Star Wars quotes and what we do, and that just kind of blossomed, and now I have expanded it even further for this presentation. So I have a feeling I'll be continuing to expand and include Star Wars references as long as I'm working the Winter Weather Desk at WPC.
There you go.
Josh, this is Noah here. I was just hoping that you were going to do a Yoda voice with your with that quote, but I interrupted too. Sorry, but I see that Nolan was able to unmute, so we can. I wanted to let Henry know before we moved on to other questions.
Go ahead, Nolan.
Oh yes, Josh, great meaty presentation today. Lots of good stuff. My question is, what would you like to see CoCoRaHS do better that would help the winter weather enterprise in the weather service?
Sure. I think the number one thing, and I know this is going to be really hard to do, but getting more significant weather reports during snow events would be very helpful. You know, a lot of times our snow reports from CoCoRaHS come in, 12Z or 7 a.m. across the country, and it might be a little bit too late for our analysis or for a storm that is ongoing if it was mostly the day before. So if there's any way to push those significant weather reports that I see a lot of times for flooding more towards the snowfall reports, I think that would be very beneficial. And that would not only allow us to see more real time what's happening, but the no risk data that I mentioned, that gets updated 4 or 5 times a day. So if that data is coming in, that could also be included in the no risk and allow our verification skills or our verification scores to improve.
Thanks very much. What about freezing rain?
Yeah, freezing rain is always tricky. And as it stands right now, there's actually no true verification database for freezing rain. So any reports we can get are great, but there needs to be maybe some more robust training. Freezing rain is hard to measure, and getting those reports, they would be fantastic. But if that's gonna become a more significant part of the CoCoRaHS database, we want to make sure that the training that is available is really detailed on how to measure, because a lot of times we get very varied accumulation reports for freezing rain. But I do think that if CoCoRaHS observers were able to measure and report that freezing rain, that would be a great addition, because as it stands right now, there's no official database for verification for freezing rain.
And
good ideas.
And folks out there, significant weather reports. So if you're new to CoCoRaHS or you haven't sent one in before, this is something you can do in real time. If you see heavy rain or snow falling, You can go on the website, you can put in the amount, you can hit the button and submit those as often as you like during the event. That goes right to the Weather Service's AWIPS, which is their workstations, and they get that. And I'm sure, as Josh says, he would get them there. Josh, if you could talk to some of the Weather Service offices. I know some of them or have not really promoted that much. So maybe something from the Winter Weather Desk to the Weather Service offices out there that promote significant weather reports for snow. That might be very helpful. So that's great. Okay, we've got a couple questions coming in, and here is Blaine from Indiana, and he wants to know, does this year's winter weather outlook portend a drought situation in northern Indiana? So is this, what are we looking at there?
I think in general, and I'm not too familiar with the specifics of how La Nina impacts Indiana, and we do have a La Nina this winter, so that's driving most of our winter patterns. But I actually think, and I know it hasn't been very snowy or wet up there yet, I think a La Nina actually makes for the Ohio Valley, Indiana, Great Lakes a little wetter than normal, but maybe a little bit warmer than normal as well. So I wouldn't suggest that La Nina will produce a drought, but there are these other smaller oscillations like the North Atlantic Oscillation, which can impact that more so than just the broad La Nina. But in general, I would not say that La Nina, which we're expecting through the winter, would lead to a drought across Indiana.
Okay, thanks. And here's one from Michael. And this is a little technical here, but he's interested in climatological characteristics applied to nuclear power plant licensing. Who is responsible for reinstating the former U.S. climatology website? I'm not sure this is in your ballpark here, but his period of record was quite extensive. NCEI Snowfall Extremes database has duration of days in the stats, but does not have return period statistics. And I'm not sure if you would know that, or that's something we can ask out there and have somebody follow up with him.
Yeah, I don't have an answer to that. I would suggest that maybe the National Climatic Data Center might have some of that information. But yeah, offhand, I don't know who's responsible for that. And I don't know, I'm just reading the question here. I don't know who would be responsible for reinstating that website, but I would guess that maybe it's NCDC. I see the NCEI reference there, and that might be a contact point as well. But my first guess, and again, this is a guess, would be the National Climatic Data Center, but I don't know offhand. That's something we can look into.
Yeah, it sounds like Nolan may know something here.
Nolan. That's Richard Heim has worked a lot on that background.
And he's at NCEI. Okay, yep. Great. Ray from Missouri wants to know, as a storm spotter in their area, they usually submit a report into the local National Weather Service office. Is it also a significant weather report on CoCoRaHS, or is it a data duplication and bothersome to local offices? That is not a significant weather report, but I assume at the Weather Service office that as a spotter report, they get that at the same time. I think, the CoCoRaHS ones goes right into AWIPS, and they send an alarm off on that. I'm not familiar on how the storm spotter information works. Josh, do you have any insights there?
Yeah, that's a great question, Ray. I appreciate you asking that. I don't think that there's any harm in doing both. I was at a WFO for 10 years, and obviously the WFO itself, they want those phone calls because that's going to be more real time. They can get that immediately and get that out into their public information statement and their local storm reports. But like Henry alluded to, if you submit a CoCoRaHS report, it usually does pop up in our systems, but I don't think it actually does for significant weather reports, just the 12Z or the 7 a.m. or the 8 a.m. Daily input. So I think that doing both of those would be beneficial because the WFO would get that local storm report, but I don't know when they will send that out. Whereas if you do a CoCoRaHS significant weather report, us at the National Center, when we're tracking CoCoRaHS and looking at data, we will see that more quickly potentially than a local storm report. So I don't think there's any harm in doing both.
Great. Okay, well, thank you folks for your questions today and for your time. We also want to thank Josh for taking time out of his busy day to do the presentation. Great job, by the way. I really appreciate that. And we've appreciated you as a CoCoRaHS coordinator over the years as well. So Josh is one of our all-stars out there, and we're proud of him and just neat to watch him moving up in the Weather Service organization. So thank you. And enjoy your vacation out here in Colorado next week.
Can't wait.
You'll probably be tracking the snow yourself there on the Winter Weather Desk for what we've got coming up. Well, folks, as we close out today's program, we want to let you know that our next Weather Talk webinar will be taking place on Thursday, January 28th. You want to mark your calendars. It's one of our annual favorites. And believe it or not, it's been 5 years since we've featured one just like it. I'm referring to the review of the top weather events of 2020. It's been traditionally given by meteorologist Greg Carbon, also of the Weather Prediction Center, and he'll be doing this one. So you won't want to miss this one. Again, Thursday, January 28th. We'll have that on the website. We'll have the registration information up on our website shortly. So before I forget, when signing off today, please take that short survey that'll pop up on your screen. Until we meet again, stay safe and have a healthy and happy holiday season.